Hello and welcome to the channel. In this video, let's discuss about the clotting mechanism of blood. When there is a damage to a blood vessel, our body has a special ability to stop the bleeding via blood clot formation. This process is called as haemostasis. Haemostasis is a very vital function. Coagulation is a cascade of events which leads to formation of blood clot. Clotting factors are proteins which will be activated and carry out the coagulation process by activating other clotting factors as well. There are two pathways depending on how the process is started, and both pathways do proceed in same pathway, which is called as common pathway. The extrinsic pathway, this is triggered by external trauma which will cause blood to come out from the circulation. The intrinsic pathway, this is triggered due to internal damage to vessel wall. Extrinsic pathway, damaged cells outside of the circulation releases factor 3. As the blood vessel is also damaged, factor 3 is exposed to blood. Factor 7 is found in the blood and vitamin K is needed for the activation of factor 7. Activated factor 7 forms a complex with factor 3. For the formation of this complex, another ingredient is needed. That is calcium. This complex activates the factor 10 into the active form. Intrinsic pathway. This pathway begins with the activation of factor 12 or the Hageman factor. Factor 12 gets activated when they are exposed to negatively charges collagen on the damaged endothelium of the blood vessel. Then activated factor 12 activates factor 11. With the help of calcium ions, activated factor 11 activates the factor 9 and then the factor 8. Factor 8 and calcium forms a complex to activate factor 10. Factor 8 is also found in the blood and usually activated by thrombin, which is the factor 2. Common pathway. The extrinsic and intrinsic pathways are converged and continue with the common pathway. Common pathway starts with the activation of the factor 10. Activated factor 10, 5 and calcium binds together, forming prothrombinase complex. This prothrombinase complex then activates prothrombin, which is the factor 2 in inactive form, and activates into thrombin, which is activated factor 2. Thrombin cleaves fibrinogen, which is factor 1, into fibrin, activated factor 1. Also, thrombin cleaves factor 13 into active factor 13, which binds with the calcium and create fibrin crosslinks to stabilize the clot. Thrombin has several functions as you see. Activating platelets. Activating factor 5, 8, and 9. Regulation of the clotting pathway. There are some proteins which provides negative feedback on the clotting cascade. They are protein C and protein S. Protein C is activated by the thrombomodulin, which is activated by thrombin itself. With the help of protein S, they degrade the activated factor 5A and 8A, causing slowing down of the clotting mechanism. Also, the calcium ion is essential ingredient for the extrinsic, intrinsic, and common pathways. So low levels of calcium ions act as inhibitory to the clotting cascade. Antithrombin is a protease inhibitor that degrade thrombin factor 9A, 11A, and 12A. It is constantly active and further activated by heparins, which is a group of anticoagulants. That's it for this video. Thank you for watching. Subscribe for more. Artificial love. Artificial love. We just make it up.